Hi there. In this lesson, we're going to look at how to use Spring Boot's built-in persistence tools to allow us to store our model objects in a relational way in a MySQL database. So this lesson assumes that you've already done the setup work in the article that preceded it. So if you haven't done that, go ahead and hit pause and go back to the course page and do that setup work to install MAMP and get your application ready using the specific dependencies we need, and then you'll be ready to go. So let's just look at very briefly what you did in that setup lesson. The first thing you did was to add two dependencies to your Gradle file. So build.gradle specifies, among other things, the dependencies or the external third-party libraries that your application uses. And so we added two. We added the Spring Boot Starter Data JPA dependency, and then we added the MySQL connector Java dependency. And so these two together will allow us to use some Spring data tools and JPA tools and a tool called Hibernate to store objects in a database. And the MySQL connector will specifically allow our application to interface with the MySQL database. And then you also added some settings to your application.properties file, and these will enable the application to connect to the local database running on your machine, and we'll configure a few basic behaviors for us. And we'll mention a couple of these as we go forward in this lesson. So that's what you've already done. Other than that, we're starting with the same application that we left off with from the last lesson. So let's look at our cheese class. This is the class that we want to be able to store in our database. It's our model class. It's our only model class so far, or real model class. We have this enum, but we're actually going to get rid of that in a future lesson. And it's an enum. It doesn't need to be stored in a database anyway because it only has specific values. But I digress. The main thing we're focusing on is the cheese class and how we can make this persistent. And by persistent, I just mean that it is able to be persisted or stored in a database that's outside of the application. So the first thing we can do is we want to come in here, and at the top of your class, there's a new annotation that we're going to use called entity. All right, and so that annotation is a special one. That basically is a flag that tells Spring Boot that you want to store this class in a database, and that it should sort of wire things up in a right way to do that. So there's a lot of behaviors that are associated with making this an entity. In particular, one of the behaviors is that every property, or every field rather, within this class will be stored in a database unless you specify that it shouldn't be. So in particular, we have name, description, and cheese type are the properties we have so far. We also have this cheese ID, but we're going to change that a little bit in just a second. So adding an entity annotation says that all of these fields should be stored in a table that's associated with this class. So when we run our application, Spring Boot will check that there is a table in the database that is set up to store cheese objects. It will check for the columns in that table and to see if they correspond to the fields within this class. And if not, it will update that table to make sure that that's the case. So one thing we want to do here is kind of improve our code a little bit and make it work in a way that's a little bit better with Spring data. So we've been using this cheese ID property, and we've been adding it to all of our objects in this default constructor. But when we're working with Spring data, we really want to allow the persistence engine, the data layer, to really handle the creation and management of IDs for us. So let's go ahead and delete the code associated with these things. Let me get rid of these two fields. And let me get rid of the code within this constructor. I'm going to leave the default constructor, and that's because Hibernate will use it. And so we'll talk a little bit about where that constructor might get used in the future. But we want to leave it there. All of our persistent classes should have a default constructor. So let's remove the getters and setters associated with that ID. And then finally, I can remove the call to this in my non-default constructor. Okay, so I still want the idea of a unique ID within this class. However, I want to set it up so that the data layer is going to manage it for me. So when I store an object in the database, its ID is generated automatically. So let me make a private int ID field. And then above that, I'm going to add the ID annotation. And then furthermore, I'm going to say that it's a generated value. So these two annotations together say that the ID field should be an ID in the sense of a primary key. In other words, it should be unique and it should be a primary key column in the database. We talked about primary keys and how they relate to uniqueness in the intro to object relational mapping lesson. So you can go back to that if that's a little fuzzy. But that's what this ID annotation does for us. And generated value says that Hibernate, or the data layer, should generate that value for us, and it should go ahead and manage that value creation. Okay, so those two things together are going to allow us to have unique IDs for all of our classes in a really easy way that we don't have to manage in a hands-on manner. Let me go ahead and create a getter for the ID. All right, I'm not going to make a setter because it should not be, shouldn't be able to be changed outside of this class. All right, so that's all we need to do within this class to enable it to be stored within a database. Now we need to set up one more thing, which is what we'll refer to as a data access object. So let's introduce that by example. Come over to your models package and create a new package called data. And within that, I want to create a new class. And I'm going to call this cheese DAO. And so DAO stands for data access object. And so this is going to be actually an interface. It's not going to be a class, it's going to be an interface, but it will allow us to access cheese classes and will be the interface by which we interact with the database. We will not be touching the database directly. This class will be doing it for us. But like I said, this is actually going to be an interface, so let's make it an interface. And this interface should extend an interface that's part of the Spring Framework data package called CRUD repository. And this is a parameterized interface. We need to tell it that it will store cheese objects and that the keys of those cheese objects are integers. So notice here that I had to put integer instead of int. We're not able to use primitive types within the context of generics or collections. So that's why that's an integer class. That'll be kind of handled transparently in the background for us, but it's okay that this is a capital I integer wrapper class for the primitive int. So that's all we need to do for now. This interface, this cheese DAO interface, will allow us to interact with the database and to retrieve cheese objects from the database and to put those objects within the database. In particular, it extends this CRUD repository interface, and CRUD repository defines a contract. It defines several methods that, or specifies the methods. It doesn't provide the implementations of them. It specifies several methods that will allow us to put data into the database and to get data out. Okay? So our next step is going to be actually to use this interface within our controller. So let's open up our controller. And essentially our goal here is to replace every instance of the cheese data class. Every time we've used this cheese data class, we want to replace that with the cheese DAO, the data access object. So in order to just facilitate that, I'm just going to go ahead and delete this class. We've been using it as just like this in-memory placeholder for, to fill the role of a real database. But of course, we've seen the limitations of that. We're going to head and delete it anyway. That'll create some errors, but that's okay. We're going to deal with each of these errors as we go. So within my controller, I want to use the cheese DAO interface in order to interact with the database. However, I don't have a reference to it. And so here's where a little bit of Spring magic comes in. There's kind of two pieces of Spring magic. Let me first make a private cheese DAO field. And then we'll need to import that interface. And then let me add an annotation above it called AutoWired. Okay, so there are two pieces of Spring magic that are happening here. And I'll provide some resources if you want to kind of dig into these and learn a little bit more about them. They're kind of advanced, and we'll just want you to get familiar with using them rather than understanding exactly how they're working. The first is that I don't have to create a class that implements this interface. And nowhere in my code do I need to create a specific class that implements the cheese DAO interface. However, when I go to use that interface, an instance of it here, I will actually have a class that does implement that interface, and it will be given to me for free. So what happens is Spring will see that this thing is a CRUD repository, and it will understand how to create a concrete implementation of the CheeseDAO interface for me. All right, so that's pretty cool, pretty magical. We don't have to write a lot of that code. And then secondly, I'm using this AutoWired annotation. AutoWired says that I should be given an instance of this class by the framework. Okay, so I'm not going to need to say create a new instance of this class by using a constructor or by having one passed into me via a cheese controller constructor. The framework is going to go ahead and make a class that implements the CheeseDAO interface. It's going to create an instance of that class, and then it's going to populate this field sort of magically for us. Now, of course, it's code, so nothing is totally magic, but from our standpoint, we're not going to dig into the guts of how that works. It's a concept called dependency injection. We just want to understand that we're using it and understand the basics of using it in this particular situation. So just by doing this, by making that interface and by auto-wiring it, I will then have a field that will allow me to have a field that will hold a specific instance of a CheeseDAO object. Okay, so let's go ahead and go through the mechanics of replacing our usage of the cheese data static class with, or the static methods within the cheese data class with this CheeseDAO. So here in my index method, I'm basically just getting a list of all the cheeses in the system and then passing those into the view. So let's delete that and let's see how we can do the same thing with our data access object. So CheeseDAO.findAll will return all of the cheeses, and we can see that that will return an iterable. So in other words, it's going to return an object that can be looped over that will contain all of the cheeses within the database. Okay, so that's all we really need to do. That's going to be sufficient for replacing that usage. Let's see. So here, this is just displaying a form. It's not using any data. The process add cheese form, though, however, is interacting with some data. It's creating a new cheese object, and it is then adding it to this no longer existent data store. So let's go ahead and get rid of that and see how we can do the same thing with our CheeseDAO. So there's a save method provided by the CRUD repository interface that will allow me to save a new entity. So I can just say CheeseDAO.save. And then down here in display remove cheese form, this is getting a list of all the cheeses. We've already seen how we can do that. Let's say CheeseDAO.findAll. That's going to work there. And then down here, I'm removing a cheese by its ID. So we can do basically the same thing with our CheeseDAO. With the delete method, and that also takes an ID. Okay, so a couple of things we want to look at. Let's make sure that our views are still working with it. We changed the property within our cheese class, right, to be ID rather than cheese ID, and we're using that in at least one place. We're using that in the remove form. So let's go ahead and make sure that we're doing that properly. Right, so we see here we're actually referencing cheese ID. Let's go ahead and change that to just ID. And since we added a getter for that ID, that will be accessible. Recall that Timeleaf will call the getters for these properties when you use the dot notation. And that should be just fine. Everything else is the same. All right, so I think that's the only template that uses the ID. We'll find out for sure when we run our application. There's one more thing that I forgot to do. Let's go back to our interface here. So in order to make Spring Boot aware of this CRUD repository, to make it aware of this data access object, I need to add a couple of annotations. Well, one particular annotation is important, the repository annotation. This tells Spring that this interface is an actual repository and that it should manage it for us. In particular, it's going to be what enables Spring to create a concrete class that implements this interface. And there's one more annotation that's a good practice to use here, which is transactional. And this specifies that all of the methods within this interface should be wrapped by a database transaction. So a database transaction basically is one interaction or communication with the database. You can stack up a bunch of database queries and send them over to the database all at once, or you can send them over one at a time. The transactional will say that every method within the interface should be wrapped by a database transaction. So just it's a bit of a technical point there, but it's a good practice to put that on your DAO interfaces. Okay, so I think we're ready to go, and we're ready to give this a spin and see how we did. Let me just make sure that I have my MAMP application running. So MAMP is, of course, our local database. It is running. You want to make sure you have it up and running before you try to start your server, otherwise we get an exception. And I previously set it up with the right user and database name and all that, matching the configuration of my application.properties file. So if we're lucky, our application will start up and we'll be able to use it in the same way we did previously, only with persistent data now. All right, so the application started up just fine. I want to show you something really quick before we even try to use it, which is that, let me go back to MAMP here. And I'm going to open the web start page. And I'm going to go to Tools, PHP MyAdmin. This is the interface you use to set up your database and user. And if I then expand this database, I will see that I have a table here. I did not create this table. Okay, this table was created for me by Spring Boot. If you look at the startup messages here in the console, you can find the specific line. I don't know. It's somewhere in this area, the specific line where it actually created that table and the table structure for us. But in any case, know that Spring Boot did this by scanning our application. It scanned our application for classes that had an entity annotation, and for those classes, it looked for a table in the database. If it didn't find one, it created it for us, and it made sure that the structure of that table matched the structure of our classes. So if we look at the structure here, we see that we have 4 columns, an ID column, a description column, a name, and a type column. Those correspond to the 4 fields within our cheese class. Okay, and we see here we have the primary key little indicator on the ID column. That's because we annotated our ID field with @ID, and we'll also have the values of that primary key generated for us as we go. Great, so let's go ahead and I'll leave this view open, but let me open up another tab and go to localhost 8080/cheese. All right, and so no data, that's fine, that's to be expected. Let's go ahead and try to add a cheese. Okay, and that worked the same way it has been working, but let's go ahead and show you that something different happened behind the scenes. I'm going to come back over to the database here, and if I go to the Browse tab for my cheese table, I see that there's one row, and the values of this row match what is in the application. Okay, and if I add another one, I see that I have another row there and another row here. So type, note that type is represented as an integer. That's because it's an enum field. And so the value of that enum field is going to be mapped to the correct value in the class by Hibernate. Okay, so that's the basic functionality of our application. We enabled persistence within our application by doing a few things. Let's review those few things that we just did. The first thing we did was we went to our model class that we wanted to be able to store in the database, and we gave it an entity annotation. We also made sure that it had an ID field, and we specified that we wanted that ID to be generated for us by the Spring data layer. All right, and other than that, we didn't have to make any other changes within our model class. To allow the rest of our application to easily access data involving this model class, we created a data access object. And that data access object was actually an interface, cheese DAO, that extended the CRUD repository interface. So CRUD repository, we need to make one of these for each model class that we want to be able to store in the database. And so we gave it the repository annotation and the transactional annotation. And then we were able to reference that interface within our controller. And so there was some Spring magic that was done here for us. We were able to get an instance of this interface type, cheese DAO, for free, even though we never implemented the interface. Spring created an implementation of that interface for us based on some default behaviors. And we were able to have Spring give us that field, give us that object in this field automatically, and just kind of wire it directly into our controller using dependency injection, using the AutoWired annotation. And then we saw just a couple of basic methods on the CRUD repository interface, the cheese DAO interface that we were able to use to access instances of our class from the database. There's a lot more that you can do with these interfaces and with Spring Data. We're going to explore some more complicated usage of these in future lessons. In particular, we'll look at how we can deal with relationships between classes when one class has a reference to another class and both of those classes are stored in a database. And we'll also look at more complex usage of different methods off of this CRUD repository extension. And again, there's a lot of stuff here. We're not going to be able to cover all of the different usages or all the different methods, but we will definitely provide documentation and cover the most common and most useful ones for you. So that concludes this lesson. And in the next lesson, we'll look at references and one-to-many relationships within our applications.